area, to find the area of the quadrilateral, what we are going to do is actually use the previous method, but this time it will be like this. So area will be half, then modulus x1 y1 x2 y2 x3 y3 x4 y4, then x5, sorry, it's not, it will not be x5, it will be again x1 and y1, x1 y1. So see, if the number of vertices is 4, we have to write 5 such columns. This is row, this is column, so 5 such columns. Similarly, if our number of vertices is 5, we will have to write 6 columns, 7, we have to write 8 columns, and so on. So this is the actual formula of finding the area of the quadrilateral, and we are going to solve it in the same way. So we are going to keep the half here, and then start with the diagonal method, that is x1 into y2, x2 into y3, x3 into y4, x4 into y1. So we got x1 y2 plus x2 y3 plus x3 y4 plus x4 y1, and there will be a minus. Then we are going to move on to doing the this side. So we take blue, so this y1 into x2, x3 into y2, y3 into x4, and y4 into x1. So we got minus x2 y1 plus x3 y2 plus x4 y3 plus x1 y4. So now that we've written them, we have actually gotten our area of the triangle. Since we don't have any value here, so we can't proceed anymore. So I'm going to keep it in this way. So we are going to first write it in this way. So the number of columns will be n plus 1. So where n is the number of sides, so in quadrilateral we have 4 sides, so it will be there is 5 columns, such columns x1 y1 x2 y2 x3 y3 x4 y4 x1 y1, and then we are gonna multiply them diagonally first in this diagonal that is x1 and y2, and then we are gonna after completing this direction, we are gonna actually complete this direction diagonal motion. Then and before we actually complete this direction diagonal motion, we write a minus here, and then finally a modular sign and a half, and we have gotten our area quite easily. So similarly, we got a pentagon here, so the area will be half x1 y1 x2 y2 x3 y3 x4 y4 x5 y5 again x1 y1. See, now it is a pentagon and we have taken 6 columns, 1 2 3 4 5 6. So if it was heptagon, we have to take we have to take take 7 heptagon. We need to take 8 columns. Similarly, it was an octagon with 9 columns. What is the name of the polygon? I mean 10. Octa. Okay. If it has a 10, it had 10 sides. There will be 11 such columns, and so on. Okay, so this is a very easy formula, and you can easily find the area of triangle, square, quadrilateral quite easily using this method. So we are going to actually apply this method and as much as we can to actually solidify our actually solving process. So we got example to actually practice what we have learned right now. So it is a find the area of the quadrilateral ABCD with the vertices A 1 4, B minus 4 3, and C 1 minus 2, and D4 0. So area will be area will be half. Then A vertex 1 4, B minus 4 3, then 1 minus 2, then 4 0, and again vertex of A 1 4. So we got half. 1 into 3 is 3. 4 into minus 2. So minus 4 into minus 2 will be plus A. Now I'm doing in this direction actually. Okay. So plus 8. 1 into 0 will be 0, plus 0. And 4 into 4 will be plus 16. Then minus, now in this direction. So 4 into minus 4 is minus 16. Minus 16. 3 into 1 is plus 3. Minus 2 into 4. Minus 2 into 4 is minus 8. Minus 2 into 4 is minus 8. And 0 into 1 is 0. So 3 plus 8 plus 16 is 3 plus 8 is 11. 11 plus 16 is 27. So we got half into 27 minus 16 plus 3 minus 8. So minus 16 and minus 8 will combine to form minus 24 plus 3 is minus 21. But there is a minus before, so it will plus 21. So we got half into 48. That is 24 square units. So this is the actual area of the quadrilateral. So see how easy this method is.